Okay, some of you are still working on the quiz, and that's fine. We're going to go ahead and start our new material. If you want to set the quiz aside, you can finish it up in a little bit. So we've looked at the variables. We've gone translating the English, the words into variables, or a situation into the algebraic sentences with numbers and variables. And we've looked at substituting and getting that expression or that formula and having to replace the variables with the values that they take on. And as you saw in the quiz, the one example with the pulleys, most of the time those formulas represent something useful to us where the numbers can just be different depending on the situation. Well, for this next hour, we're going to take a look at how do we work with the formulas themselves if we don't have values for them. And if you recall, going way back to the beginning of the year, when we add or subtract numbers, first of all, we must have the same name. I can only combine 8 inches with other inches. And when we combine those numbers, when we add those numbers, we combine the counts. 8 plus 3 is 11, and then we keep that same name. This stays inches. When we multiplied numbers, we did not need the same name. We can take 8 feet and 5 pounds, and we can combine them with multiplication even though they have different names. With addition, we could not combine those because addition, they have to have the same name. But when we multiply, we're just going to combine the counts. 8 times 5 is 40. And then we're also going to combine the names. Feet times pounds are foot pounds. So when we start looking at variables, (9x plus 5x), they have the same name. They're both x. Just like adding 9 inches plus 5 inches would give us 14 inches, 9x plus 5x gives us 14x. How about 7x plus 3y? Trick question. Different names. That'd be like taking 7 inches plus 9 ounces. Can't do it. They have different names. So 7x plus 3y is 7x plus 3y. They have different names. There's nothing we can do with those. Now, that doesn't mean that if we have different names that there's never anything we can do. Because we can run into weird situations like this. That's not weird. There's not that uncommon. Like this. Even though there are different names here, there's still stuff we can do. We take the 8x and 4x to get 12x. We can take 5y and 7y to get 12y. It's positive, so I'm going to put a plus here, because we do have to have something that links the two of them together. So put a plus in there because it's positive. So 12x plus 12y. How about that? Can I take 3 square feet plus 11 feet? Can I add those? No. A square foot and a foot are very different. 3 square feet plus 11 feet is just 3 square feet and 11 linear feet. 11 feet. 3x squared plus 11x is just 3x squared plus 11x. Technically, what that is just a 2-digit number. Our place value system, we have a decimal or base 10 place value system. This first place value here is the 10 to the 0 or 1. 10 to the power of 0 is 1. This is the 10 to the first power or the tens place. 10 to the second power is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 1,000. The key to all this, of course, is the fact that anything to the power of 0 is 1. 10 to the power of 0 is 1. 8 to the power of 0 is 1. 52,000 to the power of 0 is 1. X to the power of 0 is 1. Anything to the power of 0 is 1. So in algebraic numbers, what we have are place values that are based off of x rather than 10. If I have a number like 749, if I write that out in expanded form, that's 7 hundreds and 4 tens and 9 ones. Sometimes written as 7 times 10 to the seconds plus 4 times 10 to the first, or just 10, plus 9, we don't write in the 10 to the 0. The same thing happens down here. This is 5 times 10 times x squared, 3 times x, 8 by itself. It's just like writing out our decimal numbers, our regular and standard numbers in expanded form. That's what our algebraic numbers are. There's a couple of big differences. First of all, algebraic numbers always have to be written out in expanded form because there is no position that implies their place value. Second big difference is in a standard number, either every digit is positive or every digit is negative. Now we saw here 749 is positive 700s, positive 4 tens, positive 9 ones. Negative 238 is negative 200s. And negative 3 tens. And negative 8 ones. Every digit is negative. But in an algebraic number, it's very possible to have 3x squared negative 9x plus 2. So each digit in an algebraic number can be positive or negative on its own. Or both. Well, no, each digit has to be either positive or negative. They can't be both. That would turn everything positive. Absolute value is a measure of distance. So if I go to add, now the parentheses here are just separating that out, just signify that is just a single number, not that there's anything we have to do there first. So I go to add 3x squared plus 7x plus 5 plus 2x squared plus 9x plus 1. Now you see also, in algebra you probably learned all sorts of strategies like drop the parentheses and combine like terms and all that. Which, yeah, that works. But this is no different than adding whole numbers. You know, way back in like kindergarten, first grade, when you started adding 3-digit whole numbers, they stressed, line up the columns, right? And we talked about this back in the first week. About the reason we do that is you can only combine digits with the same place value. So we go to add algebraic numbers, you line up the columns. And we add straight down. 5 plus 1 is 6. It's a positive 6. I'll put a plus there. 7x plus 9x, positive 16x. 3x squared plus 2x squared, 5x squared. Ta-da! We'll get to that. Don't worry. What's that? Yeah, when you multiply, the powers are going to change. When you add or subtract, you keep the same names. Now, it can get a little more complicated than that. You can have 7x squared minus 11x plus 3 plus 2x squared plus 9x minus 14. You notice you can have two digits within each place value. You don't carry it all in algebraic numbers. But still, we're going to line it up. 7x squared, negative 11x, plus 3, 2x squared, positive 9x, negative 14, and we're going to add again. 3 plus negative 14, negative 11, negative 11x plus 9x, negative 2x, 7x squared plus 7x squared plus 2x squared, 9x squared. There it is. What do you think? Woohoo! How about this one? We are now subtracting. Now again, a lot of textbooks would teach you, you drop the parentheses here and you change the sign of every term or every digit here. But again, you don't have to do that. This is just like subtracting whole numbers. 5x squared plus 7x minus 3, and we're subtracting 8x squared minus 11x plus 8. Now, we do have to work with the negatives, the integers, unfortunately, but negative 3 minus 8 is negative 3 plus a negative 8. So negative 3, negative 8 is negative 11. 7x minus negative 11. 7 minus a negative 11 becomes 7 plus 11, or positive 18x. 5 minus 8? Negative 3x squared. That's it. How would we do this one? We've got some minuses in there. The minus always goes with the digit that's after it. So this is a positive 7a. This is a negative 5b. This is a negative 4a. Negative 9b. So the 7a combines with negative 4a. 7 and negative 4 make 3a. Now this is negative 5 and negative 9b make negative 14b. And there it is. What do you think? Still better than a sharp stick in the eye? More fun than a barrel of rabid monkeys? Well, they're rabid. That's important. They're still fun. All the biting and drooling, though, might. As long as they stay in the barrel, I guess they're okay, yeah? Okay. Well, you never know. Of course, we know that x to the third means x times x times x, right? How about x to the third times x to the fourth? Well, x to the third is x times x times x. X to the fourth is x times x times x times x. Yeah. We multiply them together. How many x's do we have multiplied together? 7. X to the 7. So, rather than writing it all out, what could we have done? 3 plus 4 makes 7. Right? Even though we're multiplying, because we are still multiplying, the effect on the exponent, on the power, is that we add them together. So if I have y to the 9th times y to the 12th, I'm going to get y to the 21. 9 plus 12 is 21. Z to the 15th times z to the 4th is going to give us z to the 19th. Very good.
One way you can think of it if it's confusing is you can think of x as 1. So 1 times 1 is still 1. And then you just add your exponents.
Yeah, you can think of it that way. Yeah. I think of it this way, technically. You write them all out. Yeah. I mean, I always think of it this way, just writing them out. And of course, once you get up to 9 or 12 of them, I'm not going to write that many out. But Once you write on this saying, this is 3 x's multiplied together and 4 x's multiplied together, so now I have a total of 7 x's being multiplied together, so x to the 7th. But yeah, if that works for you, that's great. X to the 5th divided by x squared. We have 5 x's multiplied together. We have 2 x's multiplied together. And from our fractions, we learned we can divide. We divide by an x, just cancels an x out. Divide top and bottom by another x. We're left with simply x to the 3rd over 1, or just x to the 3rd. Now, Richard, you got that one quick. What's the shortcut? When you divide, you subtract the powers. Since we're going to be canceling out the x's, we have 5 x's multiplied together here, is what x to the 5th says. We're canceling out 2 of them. We're left with 3, x to the 3rd. So if I have y to the 19th divided by y to the 12th, I'm going to get y to the 7th. Z to the 43rd divided by z to the 41st. I'm going to get z squared. Very good. X to the 3rd to the 4th power. Well, that's x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Or yeah, we got a total of 12 x's being multiplied together, or x to the 12th. Shortcut would be just to multiply. 3 times 4 makes 12. So y to the 9th to the power of 5 is going to be y to the 45th. Z to the 5th to the power of 12 is going to be z to the 60th. Woohoo! If it's a power of a power, you end up multiplying the powers. Yeah. Again, you're taking it to a power, but the appearance is you're multiplying the powers. So if I have something like this, 7x to the 5th times 3x squared, we multiply the counts. What's 7 times 3? 21. And we also multiply the names. X to the 5th times x squared, x to the 7th. What if we have multiple names? Well, 9 times 4 is 36. X to the 3rd times x squared is x to the 5th. 3 plus 2. How about y? Y, it actually has a power, we just don't write it. What is it? The 1. So y times y to the 5th is y to the 6th. 1 plus 5 is 6. That's not so bad. Okay, well, I want to give you some time to work since I cut you short on the work on the first hour. So in the big book, and we're going to come back and we're going to review these rules of exponents here shortly. But in the big book, on page 333, exercise 13-2, and on page 335 through 336, exercise 13-3. Give you some practice on these.